quadcopter control with leap motion. The idea behind this was based on kind of a kid's dream to be able to move an object across the room with just your hand. So it was really cool to develop this system that kind of gives you that power. The overall idea behind this is to use the leap motion, which is an infrared sensor that can track your hand in three-dimensional space. So you use the bank controls to map that quadcopter. This movement from the leap motion sensor is passed to a computer, which analyzes all the calculations and puts that into a transmitter that comes with the quadcopter that is then sent to that and directly does that control.
Charlie the painter in Japan. We have grown apart.
For this project, we decided to create 3 different stages that we wanted to achieve. The first stage involved creating an entire new system to control a drone with our hand. On the next stage, we wanted to be able to control 2 drones simultaneously with our hands so that they would move in parallel matching movements. And for the final stage, we integrated everything that we did throughout the project so that we could actually control individual drones in the fleet and control them individually and switch between them.
Since our end goal was to get to a system that relies only on hand motions, essentially our hardware team had to go from replacing the joystick controller that actually existed on the device to a system of our own using IR sensors. Our team figured out that the joysticks actually act as potentiometers that limit the voltage input to the chip already on the transmitter board. So what we had to do was take out these potentiometers and replace them with our signals that we generated from our minnow board microcontroller. Since the signals that we were receiving from the minnow board were PWM signals, our transmitter chip could not read those, so we had to smooth them out using a low-pass filter. We determined the values of the capacitance and the resistance needed for this low-pass filter to get our transmitter chip to read these signals that we generated.
So we designed the software for our leap motion system to be as modular as possible to account for any changes in hardware that took place. Our software is designed to fit within the Leap.js plugin system, which is a collection of open source plugins to work with the leap motion. This means that controlling your quad can easily integrate with other open source projects that define user gestures or any other control scheme. For the software portion, it was important for us to design a control schema that was both easy to operate and configurable for different levels of difficulty. With this, we added a UI configuration utility, which allows different users to input their level of sensitivity and also their desired control scheme.
The first stage of our project was definitely the most rocky one. We started out with a transmitter that did not work and went through several transmitters before we found one that worked. We encountered a problem where the drone would not sync properly with the transmitter that we had rigged up. So we had to get another drone, and once we figured that out, we were flying. But then we encountered another problem of sensitivity, both on the hardware and software ends. We had to change out some of our filters to make sure that the voltage was being supplied properly to the transmitter, and we had to incorporate a sliding mechanism for the sensitivity of the leap motion in accordance with the movement of the drone. For the second stage, once we had one drone flying in the air, it was a short set to get a second one. We found that with our model of drone, if there are 2 drones within range of the transmitter, each drone would sync with the transmitter and the commands would be sent to both drones simultaneously. Stage 3 was the culmination of our efforts with the leap motion. Once we had 2 drones moving in the air, we wanted to figure out how to switch between them and operate them individually. We did this by incorporating the left hand into the motion by using your fingers to signify how many drones you'd like to control, 1 being 1, 2 being the second one, and so on. Once we accomplished this, our main goal was achieved, and we felt that the project had come to its full realization.
So we've had a lot of ideas in mind for applications for our projects. One of the main things we've accomplished is a very easy to use and intuitive control scheme for drones. If you've ever tried controlling a drone with a typical joystick controller, you know there's a pretty big learning curve to it. Our mobile drone system could also be used as an aerial photography type system, which is also a big application of drones today. Typically, you have one person controlling the drone and you have one person controlling the camera. With a system like ours, you could use one hand to control the drone and one hand to control the camera, essentially making a two-person job into a one-person job. We also think that our project could also have a lot of commercial applications. Kids and hobbyists alike would love to play around with our project. Flying a drone with just a movement of your hand is simply just a lot of fun.
And then I saw you there. Been working like a dog. I turned all my dreams off. I didn't know my name. I didn't know my name. I got a little bit longer. I got a ways to go. I got a little bit longer. I got a ways to go.
So overall, the project really was a challenge of hardware and software combined that really tested our skills. Hardware, we had to solve problems with the transmitter. I went through a couple of them, had to figure out how to get those to work. Some software team had to really focus on a lot to get this working, and we ended up with a really robust code that really works well for our system and really is expandable. Overall, our project really was a great success. We are really proud of how everything worked out and that we were able to accomplish every single goal and even push into beyond into other applications. Overall, we were really excited to work on that.